We're going to use the same series of steps I've demonstrated in my previous video to tackle this problem with connected particles. Hopefully this will convince you just how versatile these steps are. With connected particles, what you are really doing is carrying out all of the steps for each individual particle in turn. But when it comes to the final step of solving the equation, it's almost certain there'll be simultaneous equations that you'll need to solve. It's also worth mentioning that the direction of acceleration must be consistent between the two particles, as I'll explain. So here we have step 1. And just notice that since the magnitude of tension on one end of the rope is the same on the other end, we can use the same label T in both cases. It's easy to see the direction T is acting in each case. Just remember, you can never push a piece of string. The only way a rope can apply force to this 2 kilograms mass is by pulling away from it. And similarly, the only way a rope could apply a force to this 5 kilograms again is by pulling away from it. And that's why the direction of the force is always away when you're dealing with a rope. As before, don't forget to show the direction of acceleration with a double-headed arrow. And here we can see I've ensured my directions are consistent. In other words, if I have decided that I think the acceleration is going to be from left to right here, it stands to reason the acceleration is going to be down here as far as this particle is concerned. Step 2 is choose perpendicular directions dictated by the direction of acceleration. And remember, as I said before, effectively you'll be carrying out all of these steps for each object separately. For the 2 kilogram mass, this is the most important direction, and this is perpendicular. And for the 5 kilograms mass, this is the most important direction, and here's the perpendicular. Step 3, resolve all forces as necessary. So for each object in turn, we're going to resolve the forces so they are all in these perpendicular directions. The great thing about Pulley questions is that although they may be more difficult in that they have 2 objects, very often at least one and sometimes both of the objects have the directions of their forces already fully resolved in your chosen direction. And indeed in this example, there's no work to be done on the 5 kilogram mass. The only forces acting on the object, tension and weight, are already resolved in our chosen directions. We have to do a little bit of work with the 2 kilogram mass to resolve the weight into 2 components acting in our chosen directions. And again, I'm just going to present you with the answer. If you aren't certain how to do this, look at my other video in this series. So here we have, for each object, all forces resolved into their own particular perpendicular directions. Step 4 applies individually to each mass. So we look first at the 2 kilograms and we choose either of our directions and write down the direction that we're considering first. We're just going to collect all the forces in this direction, taking into account whether they agree with the direction of the arrow or going in the opposite direction. And finally, we're going to set this equal to mass times acceleration. But again, in this case, there is no acceleration in this direction. The object isn't jumping up off the surface of the inclined plane, so it's equal to 0. We're going to do the same in the other direction. And we're going to set this equal to mass times acceleration, but in this case we know the mass is equal to 2 kilograms. Now we turn our attention to the 5 kilogram mass. Again, we'll choose one of our directions and write it down and collect forces. And we'll set this equal to mass times acceleration. Similarly, we'll choose the other direction, but of course it won't take you long to realise there are no forces in this direction, and if we set it equal to mass times acceleration, well, there is no acceleration in this direction either, so it's a trivial equation. Step 5 is solve equations. This is now just about pure maths. You have a number of equations with a number of unknowns, and if your pure maths is good, you'll just be able to solve this. You don't really need to understand much about mechanics to solve these equations. However, you'll soon get used to expecting connected particles to almost invariably be about simultaneous equations, and we can see this is the case here. We see this equation here has two unknowns, t and a, and this equation here also has two unknowns, t and a, so we can solve these equations. We're going to, because it's acceleration we want to find, we'll eliminate t. Now this video isn't really about solving simultaneous equations. It shouldn't cause you any issues to be able to solve this pair of simultaneous equations. What I would do is rearrange for t here. So we would have t equals 5g minus 5a, and substitute this into this equation here. And finally, you'll find that a is equal to 4g divided by 7. And of course, if you want to substitute in 9.8 here, you can find a numerical value.